the last objective we learned today is estimate the production of tractor and dozer. So you see a dozer, a wheel dozer. So let me write down a few notes before we move on. Dozer, there are two types with the crawler. Or you can say track dozer. That's something we see in the previous video. Just basically track or crawler dozer with the track in there. And then the second type of dozer that you see in this finger from Caterpillar, that is the wheel dozer. So let's write down here. So what is the application for each of them? I just write down a few notes. First one, for this, it will be suited for the rough terrain. Suited for rough terrain or low tractability. Low trafficability. And then, of course, it's good for steeper side slope. Steeper side slope. It will use the crawler dozer. And of course, it will have a low ground pressure. So that is the when we use for crawler track dozer. The second wheel dozer that you see in here, use wheel. So of course there's some advantage. Of course, it has higher speed, not low trafficability at above. So as you can see, it will be a higher speed, that for sure. And of course, no damaging for the base surface, or minimal. No damage to base, like asphalt. And then high ground pressure. High ground pressure that the equipment created on the surface. So let's go over a few information that you have here. For example, the dozer, and they have a different kind of plate: straight plate, angle plate, universal plate, and cushion plate. And as you can see that some different in there. For the adjustment of the plate, there can be tilting, the one you see the front, or pitching up down, and also it can be angling to left to right for the plate. To determine the cycle time, of course, like I say, it's fixed time and variable time. The fixed time, it depends on the operating condition. You have the fixed time in this table, and this is the table for 4. And then we can also determine the speed, basically to determine the variable time or travel time for different scenarios. The first one is dosing, when they dose the material or return with empty blade. So we have speed in there. So apply that into determine the productions. We have equation for the production. So, and I write down here, and then we apply for problem 3 to determine production of the dozer. It very simple. It equal to the volume per cycle. So basically, how much a blade can carry per cycle. Time, how many cycle per hour. And then we time efficiency factor. So something we did in lesson 2, efficiency factor. And that's what we are going to apply in this problem 3. So for problem 3, a power ship crawler, so that is the keyword here, the power ship, so that we can use the table correctly, has rated blade capacity. So this is basically volume per cycle. Excavating a loose commoners, so loose, that is keyword, pushing a distance 250 feet. So dozing and return 250 feet for each way. The maximum reverse speed in the third range, 5 miles per hour, so that it return. Estimate the production of the dozer if the job efficiency is 50 minutes per hour. So production, so we can write out that equation again, production, and find out what we already have and what we are not have, and we need to looking for volume per cycle, time cycle, number of cycle per hours, per hours, and time efficiency factor. We already have efficiency factor here, 50 minutes per hour. We already know volume per cycle, 10 loose cubic yard. What we need to do is just how many cycle per hour. That is the key. How to determine the cycle per hours. First, to determine the cycle per hours, we need to know what is the cycle time. First thing first, cycle time. And as we learned at the first video of this lesson, cycle time determined by fixed time plus variable time. So that's what we need to do. Then we need to find out fixed time, and we need to find out travel time. Add them, we can find out cycle time. Then let's do here to go to first thing first, fixed time. And fixed time, you use table 4 and that will be power shift. So 4 go here, power shift transmission, dozer fixed cycle time 0.05 minutes. Okay, so write down here. So you have fixed time 0.05 minutes. And then we need to find out the travel time. To determine the travel time, the problem gives you a distance. We need to find out the travel speed, right? Travel speed. And there are two scenarios, dozing speed and return. So to find out the next one is what is the travel time. And travel time, we need to find out the speed first. So first we have the dozing speed. And that will be in table 4.5. And in table 4.5, go down to here. Rosin and loose material and hold 250 feet. So it will be 5 mile, 2.5 mile per hour, 2.5. And return, if it over 100 feet, the problem give you 250 feet, the maximum reverse speed in the third range. And in the problem, they give us that is 5 mile per hour. So from that, we can have this one, of course, 2.5 mile per hour. So when you have speed, we can find out the time, right? The first one, we have dosing time equal to 250 feet divided by speed 2.5 mile per hour, and of course we have to put 88 feet per minute for every mile per hour to get the minutes. So from that one, we will get that equal to 1.14 minutes. And then we can also determine the returning time. Returning time. It equal to, of course, return another way, feet. And for returning, it will be the maximum reverse speed in the third range is 5 mile per hour reverse. So they don't turn, just go backward. 5 mile per hour, and unit conversion, we have 88. So from that, we will get this one equal to 0.57 minutes. And that we can have the cycle time. Cycle time in this case, as you can see now, the cycle time is equal to add them up. Fixed time 0.005, dosing time 1.14, return time 0.57. So from that we can have 1 point, we get 1.76 minutes. 1.76 minutes. So from that we can have the number of cycle per hours equal to 1 divided by cycle time, but have to be in the same unit, hours per hours. Cycle time we calculate per minute, so it will be, as you can see, 1 have to time 60 minutes per hour, and then we divide by the 1.76. So from that we can have the number of cycle hours is equal to 34. So that 1 hour, this can go back and forth 34 times. So from everything else we already have, so we can have production is equal to cycle volume per cycle 10 LCY loose cubic yard time number of cycle 34 per hours, 34 cycle per hours, time the efficiency factor 50 minutes per hour, so it will be 50 minutes over 60 minutes per hour. So from that we have it 283 loose cubic yard per hour. And that is the answer for this. So for 1 hour, the dozer can generate 283 loose cubic yard. So with that, we are done for lesson 3.